My name is Karthik Venkat, and I am a researcher in the information sciences at Stanford University. My recent work has focused on developing new estimators for quantities of interest that operate on these large dimensional objects and then come up with new algorithms to boost the performance of various machine learning and artificial intelligence applications, such as, say, learning graphical models, ranking images in a database, testing how well Google or say a language model can process the speech of human beings, and so on.
Karthik's fearlessness in the face of disciplinary boundaries, I think, really emblematic of much of the spirit of this award. So he can run the gamut from the highly theoretical and abstract all the way to the concrete and practical and applied to really make significant contributions and impact on important problems.
Being an EE major, I was trying to look for domains where I could apply mathematical insights to improve the performance of engineering systems.
He was able to notice that some of the problems in machine learning, such as learning graphical models, are at their heart communication problems.
What really excites me about being a young scholar at the Marconi Society is the potential for impact that as a group we can have on society as we take information and communication sciences forward into the new decade. For example, there is an exciting Celestini project that the Marconi Society is working on in Uganda. And there are a lot of other expansion projects we are thinking of in India and a lot of other countries where we want to empower students to create new technologies and help them or assist them through mentorship to do so.
My name is Joseph Lukens, and I am a research scientist. The general goal for all the research that I've done, sort of up to this point, has been how to improve communication security. In one of the areas that I looked at, called temporal cloaking, just as one can imagine a spatial invisibility cloak that you put on and you can hide yourself from anyone looking at you, you can actually extend some of these ideas in time to imagine hiding information transmitted down optical fibers.
In particular, Joseph worked on cases where pairs of photons had interesting correlations and demonstrated some ways to take advanced ultrafast optics and telecommunications technologies and exploit them for essentially signal processing on such biphotons in ways that we believe may help the development of quantum key distribution.
It is actually possible to ensure security in communications by using quantum states of light. And one of these areas that's a difficulty is the speed at which we can communicate using quantum key distribution. It's generally much, much slower than state-of-the-art classical communication. For example, we showed that it was possible to encode information in photons using techniques that hadn't been developed in classical code division multiple access. But there are a lot of challenges, I would say, from taking the ideal theoretical perfection and actually applying it in real world systems.
Joseph is the best natural communicator I've seen in many, many years as far as, sort of the engineering and the science that we do. He's really gifted in explaining his work in a way that people at different levels can connect to and appreciate. From explaining results in group meetings to talking to the media, as he had much occasion to do when he published his first Nature paper.
As a Marconi Young Scholar, I feel a challenge to succeed in the future. If such esteemed leaders in the field see all this potential in me, I feel like I really want to prove them right.
My name is Ken Pacina. I am a PhD candidate in electrical engineering at the University of Texas, and I'm also the CTO of a startup company called RadioSense. My research is in the area of centimeter accurate positioning for mobile devices. And my research in particular has been focused on a technique known as carrier phase differential GPS. Very neat processing to be able to extract from the carrier phase much more information regarding your position.
Well, Ken has been diligent, and he's just worked methodically, trying to address the critics that would say that this is impractical or couldn't be made reliable.
One of the main challenges with my research and getting this carrier phase differential positioning technique to work on these low-cost platforms is overcoming what's known as the time to first fix. And this initialization time can be much longer than what people have traditionally come to expect when they turn on their iPhone and start using an application that uses their position.
It's also a question of choosing the right questions to pursue.
A grad student in the wireless networking and communication group who went and started to work for Samsung, he called me up and he asked, how hard would it be to get your software to work on a smartphone? And we ended up working out a contract with Samsung Research America that went on for 2 years. Another area more tailored toward mobile devices and smartphones is in the area of virtual reality and augmented reality. You can take your smartphone even today and you can put it in one of these Samsung Gear VR headsets and you can immerse yourself in this virtual world.
In fact, we're not even trying to guess about how it might be used in the future, but we recognize that this is the next big thing.
Being accepted as a Marconi Young Scholar means that I'm able to meet and join a community of a lot of great minds. These guys have done a lot of great stuff in the industry. Just looking at some of the past award winners, it seems like they've had a huge impact on society. They've taken their research and they've done something with it in a real impactful way.